Hi there, welcome back to Spring in Math 7. I'm Mrs. Campbell. Today we're going to be talking about multiplying and dividing rational numbers. Let's get started. So whenever we multiply a number by -1, the sign of the number changes. In more mathematical terms, multiplying by a -1 maps a number into its opposite. The number line below shows two examples. 3 times -1 equals -3, and -1 times -1 is +1. When we multiply a number by -1, the absolute value of the new number is the same as the absolute value of the old number, since both numbers are the same distance from 0. The product of a number x and its negative is -x. It doesn't mean that -x is necessarily less than 0. If x itself is negative, then -x would be positive because a negative times a negative, -1, is a positive. When you multiply an expression by a -1, remember to multiply the entire expression by the -1. Here's an example. Multiply the following by -1. 79.5, x plus 1, the absolute value of x. It's pretty simple. That turns into -79.5, -x plus 1, or -x minus 1, and negate or make negative the absolute value of x. So note that in the last case, the negative sign outside the absolute value symbol applies after the absolute value. So multiplying the argument of an absolute value equation, or the term inside the absolute value symbol, doesn't change the absolute value. X is always positive, and negative absolute value of x is always negative. So whenever you're working with expressions, you can check your answers by substituting in numbers for variables. That helps too. All right, let's talk about multiplying rational numbers. Simplify 1/3, and that's supposed to be times 2/5. So one way to solve for this is to think of money. For example, we know that 1/3 of $60 is written as 1/3 plus $60. We can read the above problem as 1/3 of 2/5. And here's a visual picture of the fractions 1/3 and 2/5. If we divide our rectangle into thirds and one way and fifths the other way, then here's what we get. This little graphic. This is the intersection of the two shaded regions. The whole has been divided into 5 pieces widthwise and 3 pieces heighthwise. We get 2 pieces out of a total of 15 pieces. So our solution is 1/3 times 2/5 equals 2/15. Now, when we're multiplying fractions, remember a over b times c over d equals ac over bd. An example, 2/5 times 5/9. So with this one, we can cancel the 5's. 2/5 times 5/9 equals 2 times 5 over 5 times 9. We cancel out those 5's and we get 2 over 9. Here's another example. 1/3 times 2, 7 times 2 over 5. And with this problem, we enumerate all the numerators and all the denominators, and we get 4 over 105. It's important also that you're able to identify and apply properties of multiplication. Remember, the 4 mathematical properties which involve multiplication are the commutative, the associative, the multiplicative, and the distributive properties. The commutative properties, when 2 numbers are multiplied together, that the product is the same regardless of the order in which they're written. For example, 4 times 2 is the same as 2 times 4. The associative property says when 3 or more numbers are multiplied, the product is the same regardless of their grouping. So 2 times 3 times 4 is the same as 2 times 3 times 4. The multiplicative identity property says the product of 1 and any number is that number. For example, 5 times 1, 5. The distributive property says that the product of an expression and a sum is equal to the sum of the products of the expression and each term in the sum. For expressions A, B, and C, A times B plus C equals AB plus AC. Or for example, 4 times 6 plus 3 equals 4 times 6 plus 4 times 3. Let's look at a real-world problem using multiplication. Annie has a bar of chocolate and she offers Bill a piece. Bill quickly breaks off 1/4 of the bar and eats it. Another friend, Cindy, takes 1/3 of what was left. Annie splits the remaining candy bar into 2 equal pieces, which she shares with a third friend, Dora. How much of the candy bar does each person get? Let's look at this problem visually. Annie starts off with a full candy bar. Bill breaks off 1/4 of the bar. Cindy takes 1/3 of what's left. Dora gets half of the remaining candy bar. And we can see that actually each person is going to get an even amount. Okay, the identity element is a number which, when combined with a mathematical operation on a number, leaves that number unchanged. So for example, the identity element for addition and subtraction is going to be 0 because adding or subtracting 0 to a number is not going to change the number. And 0 is also what you get when you add together a number and its opposite, like 3 and negative 3. Now the inverse operation of addition is subtraction. When you add a number, then subtract that same number, you end up back where you started. And also adding a number's opposite is the same as subtracting it. So for example, 4 plus negative 3 is the same as 4 minus 3. Now multiplication and division are also inverse operations to each other. So when you multiply a number and then divide it by the same number, you end up back where you started. Multiplication and division also have an identity element. When you multiply or divide a number by 1, the number doesn't change. Just as the opposite of a number, highlight that, is the number you can add to it to get to 0. The reciprocal of a number is a number you can multiply it by to get 1. And finally, just as adding a number's opposite is the same as subtracting the number, multiplying by a number's reciprocal is the same as dividing by the number. To find multiplicative inverses. So the reciprocal of a number x is also called its multiplicative inverse. Any number times its own multiplicative inverse equals 1. And the multiplicative inverse of x is written as 1 over x. So to find the multiplicative inverse of a rational number, we simply invert the fraction, that is, flip it over. In other words, the multiplicative inverse of a over b is b over a, as long as it doesn't equal 0, as a doesn't equal 0. Here's an example. Find the multiplicative inverse of the following: 3/7, 3.5, negative x over y. The solutions are actually pretty simple. 3/7 equals 7 over 3. 3.5 is the same as 7 over 2, so that would be 2/7. And negative xy would simply be negative y over x. So earlier we mentioned that dividing by a number's reciprocal is the same as dividing by the number. And that's how we can divide rational numbers, to divide by a rational number. Just multiply by that number's reciprocal. So in more formal terms, a over b divided by c over d equals a over b times d over c. This question asks us to divide the following rational numbers and give your answer in simplest form. Go ahead and pause your video and give those a shot. So how did you do? The solution is you would replace 1/4 with 4 over 1 and multiply. 1/2 times 4 over 1 equals 4 over 2, or 2. For B, replace 2/3 with 3 over 2 and multiply. 7 over 3 times 3 over 2 equals 7 over 2. And for C, x over 2 divided by 1 over 4 equals x over 2 times 4y divided by 1, or over 1, equals 4xy over 2 equals 2xy over 1 equals 2xy. Last one. Let's look at a real-world problem using division, including speed, distance, and time. Remember, speed equals distance over time. So Andrew's driving down the freeway. He passes mile marker 27 at exactly midday. At 12:35, he passes mile marker 69. At what speed in miles per hour is Andrew traveling? So to find the speed, we need the distance traveled and the time taken. If we want our speed to come out in miles per hour, we need distance in miles and time in hours. So the distance is 69 or 42 miles, 69.27. The time, minus 27 or 42 miles. So the time is 35 minutes or 35 over 60 hours, which reduces to 7 over 12 hours. Now we can plug in the values for the distance and time into our equation for speed. So the speed is 42 over 7 over 12 equals 42 over 1 times 12 over 7 equals 6 times 7 times 12 over 1 times 7 equals 6 times 12 over 1 equals 72. So Andrew is actually driving 72 miles per hour. All right, everyone, that just about does it for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.